Now we're live. Take it away, Jay.
Hey! What's up, YouTube?
What's up?
It's Professional Data Management. Pro Data Man, right here, live and direct. My man, Antoine Victor. Yours truly, Jay Doré, and today we're going to talk to you about continuous delivery. There's a lot of misinformation out there. There's a lot of misunderstanding. So we just wanted to do a very high-level view and clarify a couple things that we've heard people have questions on. And we're going to discuss this stuff right now. Because we've got the big boss, the expert, Antoine. He knows all this stuff.
Okay. Yeah, so there's a blog post. It hasn't come up just yet, but I'll post that during the course of the discussion here. But basically, we see the terms CI and CD thrown around quite frequently.
Exactly.
And more often than not, people aren't really clear about which CD they're referring to
Right,
when they say CI
delivery
and CD.
Or deployment.
Right? So we just want to make sure that we clear up that confusion there.
So here at Pro Data Man, we ask the tough questions. My question is, what did one elevator say to the other elevator?
My question is, what happened to my button? What did one elevator say to the other elevator?
He said, I think I'm coming down with something. In response, the other elevator said, well, I'm coming up with something better. And that's what we're going to do for you. We're coming up with something better.
Alrighty then.
Now, I wanted to ask you this for a long time. In your opinion, or not even in your opinion, this is pretty much fact. Is it possible to implement continuous delivery without first using continuous integration?
That's a good question. Since we quite frequently hear them referred to in concert.
Yeah.
Continuous integration, let's start there.
Okay.
Continuous integration is basically the idea of integrating changes made by multiple developers, not just developers, multiple team members, into either a single branch or into a single repository where we're storing the code.
Right.
Right. So if we've got multiple developers, maybe some outsourced guys in another country, another time zone, or what have you, and they're making changes, they're probably making changes to code that has some external dependencies.
Okay.
For example, maybe you're calling a service that's being created by another developer, or maybe it's an off-the-shelf service, but something that isn't under your direct control, or maybe it is, but it's being changed potentially by other developers.
Right.
So those developers are making changes in other locations. We want to make sure that everybody has the latest and greatest.
Yeah.
If you make those changes and you don't compare them to what other developers have done, you might be developing yourself into a corner.
Sure.
For example, if somebody made a change to that service that you depend on, and the change that they made makes your code break,
Mm-hmm.
if you only have a copy of the code from before they made the change on your local machine, then you're developing, everything looks awesome, you're getting ready to pack up and go to Tahoe, but you don't know that your code is going to fail.
It works on my machine.
It works on my machine. If you're curious about what I mean by the Tahoe effect, see our post, Avoiding the Tahoe Effect, by clearly defining done. I think it's called Are We Done Yet?
Yes.
Anywho, so we want to combine or integrate all the code from the different developers whenever we make changes to make sure that we're not missing something that another developer did.
Okay.
So we get those changes that the other developer did that break my changes. Then I say, oh snap, I can't go to Tahoe now, I have to fix this bug.
Right.
Otherwise all the other developers are going to be pissed off at me.
Right.
So what we do with continuous integration is we take the code changes that we've made, we check them into source control, which combines them with the changes that other developers have made and checked into source control, and then it tries to compile it or build it, as it were.
Gotcha.
So,
okay.
If that succeeds, then the build is golden, and then we run automated tests. Hopefully, if we're truly doing continuous integration, we have some unit tests defined,
right.
Some integration tests defined. That's so that when we check all that code into the central repository, all the tests run, or rather the build happens, the build is successful, all the tests run, and if either one of those things fail, we should assign a bug back to the developer that committed that bad code to source.
So when we say integration, then we're talking about new code that's introduced to the build and testing that code to make sure that it works. Sorry.
Yes.
Sorry, Peter.
So
in regards to continuous delivery, is it possible to do continuous delivery without first doing that?
is it possible to do continuous delivery without first doing that? Well, technically, yes.
But not well.
Yeah. You basically be continuously delivering defects very rapidly into QA or wherever you're continuously delivering to, right?
Right.
So I wouldn't advise doing that.
Okay.
It seems that we've got incoming calls.
We're popular. That's what you get for being popular.
Anywho, that's weird. I just noticed this shot's kind of trippy. That totally derailed my train of thought. So is it possible? Yes, it is technically possible, but you should not do it that way. You should climb the stairway to DevOps, as I like to say.
Yeah, I was actually answering my own question as you're explaining it. As I'm asking the question, I'm thinking, yeah, it's going to be possible, but you can't do it the correct way.
Right.
Or a way that's going to benefit your client. So you mentioned that this isn't just for developers.
No.
So if I'm trying to convince the guy who pays for the training and pays for the consulting services that we need to implement continuous delivery, how long can I say that this is going to take to implement it successfully for like a small to medium-sized business?
It depends on the culture, really.
Okay, right.
I mean, a lot of times you're coming from a waterfall culture,
right?
Which, I mean, there might be ingrained habits and deep culture that resist the change to Agile and DevOps.
Which that's the worst case scenario, right?
Worst case scenario, but as an example, companies like GE Oil and Gas. Now that's maybe not the best example because GE Oil and Gas has like $5 billion in R&D money.
Huge.
So they've got lots of R&D money
Sure.
that they can kind of point at whatever problem.
Right.
But as an example, by the way, you can find a link to the GE Oil and Gas case study at prodataman.com. We'll put the link in the description. But the GE Oil and Gas case study talks about how they did kind of a rip and replace of their existing process and culture, really.
Right.
And went away from waterfall into DevOps in, I want to say it was 18 months, but it might have been 14 months.
Wow.
Let's call it 18 months.
Okay, yeah, to be safe. Sure.
So 18 months, and it cost them, if I remember the numbers correctly, about $14 million.
Okay, wow.
Right. So
That's
they spent $14 million in 18 months and pretty much did a rip and replace of their existing culture and environment and replaced it with a DevOps culture and environment.
Yeah.
And they came away with, this is the best part,
Okay.
they came away with a $14 million year-on-year return on investment.
Woo!
So they spent 18 months and $14 million, but every 12 months they make another $14 million. So I think it was well worth it. So to answer your question,
That's really good
18 months is how long it took them.
Right.
But like I said, maybe they're not the best example because they had a butt ton of money to throw at it.
But they're also enormous.
They're also enormous,
So-
and they were heavily ingrained in those old waterfall ways of thinking and doing business. So with that in mind, 18 months is damn good.
That's really good to know, man. That's exactly why I asked that, because we come across people often who it seems that they're under the impression that they're going to take a 3-day boot camp, they're going to implement it, and 3 months from now we're doing continuous delivery and everything's good and we're saving money.
Right.
And then whoever put the resources into that is like,
why isn't it working?
Exactly.
I thought this was Agile.
So I just want people to have a realistic view of what it is going to take to implement it culturally and technically.
Okay, well done. So back to continuous delivery then.
Right.
So you asked if continuous integration has to be done first, and I said technically no, but probably yes.
Right.
If we go down what I like to call the stairway to DevOps, a couple steps below that, before you can really do continuous integration, you have to be considering agile development.
Of course, right? Yeah.
All right. So if you're not doing that, then trying to continuously integrate, I mean, you could do it. Again, this isn't you have to do agile, you can't do continuous integration, or you have to be doing continuous integration exactly the way I'm saying it, or you can't do continuous delivery. I'm not saying that at all. But the best and least painful way to do it, I think, is to make sure that you hit some of these milestones on the stairway to DevOps here.
So this might not be where you want to start with the whole process of converting from a waterfall style culture.
Right. What I'm showing on the screen here is the stairway to DevOps.
Very good.
Right?
All right.
So, can you guys see that? Is that coming across? Yeah, it's coming across behind us. And this stairway to DevOps is, as I mentioned, the ladder that you should be climbing, the milestones that you should be hitting.
Right.
Before you even start talking about continuous delivery, you probably want to make sure that you have some discussions of test-driven development.
Right.
Because as we start to do things in an agile way, we get to shorter, faster iterations. Right. And if you're iterating quickly and you're not integrating your tests into those fast iterations, then you're basically rapidly developing defects.
Right.
So that's not a good thing either. Right. So you probably want to take a baby step and start with test-driven development.
Okay.
And I'm not going to get into the details of test-driven development here. You see the blog post about that also on the ProDataMan webpage, www.prodataman.com. Just do a search for TDD or test-driven development. There's a few blog posts out there about that. But anywho, so test-driven development means we have our tests in place. Those are the same tests that we were talking about running in continuous integration when our automated build succeeds. Right? So when our automated build succeeds, we run the automated tests that we created during test-driven development before we even started dabbling in Agile.
Gotcha.
Right? So again, the stairway to DevOps, we want to start down at the bottom there with our test-driven development and then go up to Agile development. And then we can start talking about continuous integration. And then, in my opinion, only then should we start talking about continuous delivery.
I concur. I wanted to clarify that from the master. I appreciate it. So, when you're in the process of implementing continuous delivery, what, in your opinion, I mean, you do a lot of consulting, you do a lot of, you teach a lot of classes. In your opinion, what are the biggest or most common obstacles that get in the way of successful implementation?
The most common obstacles that get in the way of a successful implementation?
Of continuous delivery.
Of continuous delivery.
Yeah.
Failure to automate.
Ah, right. Yes, that's the big one.
And really, like most other things, culture. Right? Oh, that'll never work here. Or we don't do it that way here. Or, yeah, that's impossible. We've been doing it this way for 20 years, and we're never going to do it that other way. These guys in finance will never let us do that. They always give us all the funding. I've heard all those things before, and all of those things are probably somewhat true. But the reality is, at the end of the day, if you're trying to go from one deployment every 18 months to 10 deployments per day, something's got to change.
Exactly, yeah.
And so this is why I say that the stairway to DevOps is so important, because you start at the bottom with baby steps. You implement test-driven development, and from there you say, okay, we're doing that pretty well now. Now we can do Agile. And okay, we've got this team over here doing a pretty good job of Agile. Let's see if we can spread it over here. I was at an organization not too long ago that the development team was doing so well with Agile, the marketing team was like, hey, what can this Agile thing do for us?
I heard about this, yes.
So, and they started looking into implementing Agile. So once you have that win in one small silo in the development department, they start doing test-driven development, they start doing Agile. Then all of a sudden the marketing team's like, hey, how come they're able to get stuff done on time and on budget? We want to be Agile too. Obviously, that's not entirely necessary for us to move up to continuous integration, but if you want to get to continuous delivery, and for those of you that haven't heard the textbook definition before, the textbook definition, as it were, or as I refer to it, is for continuous delivery to be ready and able. Those are the key words in the definition there. Be ready and able to deploy any version of the solution to any supported platform at any time.
Ah,
right.
Okay. That's not easy.
No, it's not. Especially if you've been used to doing it once every 18 months.
Sure,
before.
right.
Like now, if your boss comes over and says, "Hey, you nerds, go deploy that software right now." Like, are you ready to do that right now?
Right. Yeah.
Have you been branching? Do you have features that are partially complete but not ready for prime time? The tests are still failing. Deploy right now,
and it has to be flawless,
right?
It has to
with
work.
no defects,
right?
We don't want defects,
Right.
So, like being ready and able to deploy any supported version of the solution to any supported platform at any time means that you've got to be ready right now, and you haven't committed anything to the repo that might cause failures and issues.
Now, you mentioned the importance of automation.
Yeah.
Is that going to require most organizations to change or add tools to their current setups?
Most likely. I mean, they've probably, most organizations have something in place already.
But they should expect to need to change some
Yeah,
stuff.
you're not just going to wave your magic wand and be like, you are now DevOps.
Right.
You now have continuous delivery. So
Right.
if you're not already using tools like Jenkins or Team Foundation Services or one of these other build automation tools, then you've got to come up to speed on that.
Yeah.
And it's not an overnight thing, like you said, where I'm going to take a boot camp and presto changeo. I'm a DevOps engineer now.
And, there's a bunch of smart people that work in IT, so I think sometimes that is the expectation.
Yeah.
I'm just going to take
I'm
this
gonna watch
class
the
and
YouTube video,
yeah.
and I'm gonna make this DevOps thing happen.
Right.
Or we're gonna be continuous delivery enabled by next week.
So, yeah, you need to expect to take more than one boot camp. And in your opinion, do you think a consultant is necessary? An expert consultant will be necessary, or do you think they could take it by the reins and just do it themselves without any oversight?
Being a consultant, I hate to shoot myself in the foot here, but you probably aren't going to get as much value from a consultant coming in and doing all the magic and then leaving with that IP, even leaving with that intellectual property, because now they know how everything works.
Right.
Did you read that? Did you finish reading that book, The Phoenix Project?
I did. Yes.
You remember the guru Brent?
Yep.
If you haven't read The Phoenix Project, check
right.
out The Phoenix Project. We'll put a link to that in the description as well. It's like the DevOps Bible.
How did you do that?
Right? I don't know. He goes, the guru, Brent, he puts his hands on the keyboard and his eyes roll back into his head and he goes into a trance and he fixes stuff. But there's no documentation for it, and quiet as it's kept, he breaks other stuff while he's fixing it.
Right.
So everybody's like, Brent's the guru. If he can't fix it, no one can. Brent, he's our man. Anyway, the thing that you don't want is for somebody that's not on the payroll to be the Brent. Because then they leave with all that knowledge and whatever they broke. If they broke something, now you got to pay them to come back in and fix it. Anyway, that's not how all consultants work. That's not how we work here at ProData, man.
Of course not. But
well,
yeah.
what you want, if you have to go with the contractor route, though, what you want is a lot of documentation provided, processes in place so that you can replicate whatever the contractor did. Right?
And I've definitely been on that team where about once a week something breaks and it's an emergency, and the dev team is there all weekend. And that's what we want to avoid, right?
Exactly. That's why we want to do our testing first. So I brought up the Phoenix Project just to talk about Brent and not having the Brent leave after the contract is over.
Right.
But back to our continuous delivery discussion here, we have to automate to make these things happen. And it's preferable that the people that do the automation are the people that are going to be there to be able to support the automation.
Right.
Because, again, once the automation is done, if they leave and something goes wrong, or you want to change something, you want to do it again for another project, you don't want to have to hire that contractor to come back in again.
Of course.
So what you're really looking for, not necessarily a contractor per se, but more a mentor.
Okay.
Right? So somebody to come in and guide your team through the transformation.
And that was my question.
Help your team do some of the automation,
Right.
but really showing your team how to do it rather than going into a trance, rolling my eyes back into my head and like, it's fixed. Bless you, you are DevOps now, and then I'm gone.
Yeah.
I have no idea what the magic sauce was that I sprinkled on it.
My worry is that maybe an organization thinks that they're doing continuous delivery and they're not doing it correctly. And without that oversight of somebody saying, hey, no, this is what you need, they could be wasting their time or putting their resources in places that they don't belong. So that actually leads to my next question. Is there a quantifiable way that a team can assess the value of continuous delivery?
Can assess the value. What do you mean?
Is there
Before they begin, or
I suppose it would be before and after. Like, yeah, what's the marker? How do you know that you're doing it right?
if the customer's happy.
I guess that's it. If
At the end of the day, that's all we really care about is do we deliver value to the customer.
Right.
Now, I could get into Agile tracking and metrics and whatnot. But if you're interested in the metrics, there's a key DevOps Metrics post on prodataman.com also. I'll make sure you hit the www in there. But the key DevOps Metrics blog post talks about 6 or 7 key DevOps metrics.
That's what I was looking for.
I'm not going to go through the entire list here, see the blog post, but the number one is the number and frequency of successful deployments.
Okay.
Right? So obviously if the customer's not happy, that means you didn't capture your requirements properly. You didn't get the proper user stories. They weren't prioritized properly because the customer isn't getting what they wanted, even if that's not what they asked for.
Sure.
If the customer's happy, then you're winning all day long. But as far as successful releases and defect and bug-free releases, you'll get there. But if you increase the number and frequency of deployments, and there's a blog post about 10 plus deploys per day. It's a practice that Flickr implemented years ago. The idea being that the more frequently you deploy or are able to deploy, the more you must have automated.
The automation
right?
again. Automation is key.
If it took you all weekend long for the developers and the infrastructure team and the operations team, they're all locked to their desks in the server room somewhere all weekend long trying to get this crappy deployment out, that's an indication of your success at continuous delivery, right?
Gotcha.
And you should not have to take all weekend or all week or all month to prepare for and do a deployment.
So somebody
succeeding
says
at continuous delivery if you were able to do it at the push of a button at any point in time, no matter what.
That was exactly my point. So the client says, "Hey, you know what? I changed my mind. Instead of next month, I want you to do this a little bit differently, and I need it tomorrow."
Well, we're getting into rules of Agile. We want to restrict that kind of demand or request from our client.
Right.
We want to set specific release dates, but those release dates should be closer together and more frequent. A typical Agile project works on a 3.1 release schedule,
right,
where we have 3 sprints to 1 release. The sweet spot for sprints is typically about 2 weeks.
2 weeks is the...
So if you consider you do 3 2-week sprints, that's 6 weeks. Mm-hmm. So once every 6 weeks we get a release. Although, if we're doing continuous deployment, we might be deploying the updated features every single time a developer commits to source control.
That was exactly where I was going. Thank you.
Okay, so let's jump back to continuous delivery. Remember, continuous delivery just says you must be ready and able to deploy any supported version of the solution to any supported platform at any time. Not that you're actually doing the deployment, right? So at continuous delivery, that means we're doing some basic things like we've eliminated excessive branching because merging causes pain and conflicts. So if we avoid branching altogether, then we don't have to worry about merging when our boss comes over and says, deploy now, right? If that becomes the case, having to do a bunch of merging and dealing with merge conflicts for several hours or days, worst case, means we can't deploy right now, therefore we're not succeeding with continuous delivery, which is why I brought up the 10 plus deploys.
Right.
We try to deploy 10 times, not because the customer needs 10 different versions every single day, or the customer's not happy unless they see new versions being published 10 times a day. We try to deploy 10 times per day because if we can, we must have succeeded with automation. Right? There's no way we can deploy 10 times per day if it's a manual process and it requires manual tests to be run that take 48 hours for the QA team to finish running them. Right? So we're succeeding with automation if we are able to deploy 10 times per day, in which case we are totally succeeding with continuous delivery.
So that's really all I have for you. Good job, man. That's exactly what I wanted. Did you have anything else?
Well, just the rest of the stuff up the ladder there. Continuous delivery, we just clarified the difference between continuous delivery and continuous deployment. We'll get into what is DevOps and how that all fits together later.
Yes.
We touched on the culture stuff a little bit there. But I did want to show one more thing before we break out of here, and that is the reason that we care about all this stuff is because of something that I call the increasing cost of technical debt. If you bear with me for just a moment.
The increasing cost of technical debt. I love that phrase. That makes me sound smart. I need to learn it and add it to my arsenal.
There it is. Increasing cost of technical debt.
Did you make that up?
No, I don't think so.
At least you're more honest.
I've. Oops, is this a Word document? Oh, it's a Word doc. All right, well, I'm going to pull this Word doc over, I guess. I thought I had a PowerPoint version of this, but Word doc will do fine, I suppose. Bear with me for just a moment. Anyway, so what this refers to, I guess this is the, so you can find this blog post. I guess this is the document for the blog post that I put up with this,
nice.
With this slide in it. But anyway, the increasing cost of technical debt talks about how the cost of defects increases exponentially as you move towards production. So looking at this slide here, let me make sure my head's not cutting this thing off. Yeah, I'm cutting that off. So,
good thing you checked.
I slide over here. There you go. The cost of finding a defect during design is a 1x cost, meaning it costs almost nothing. It costs the cost of whoever the person is that found it to find it and design it out.
Okay.
Right. So there's a 1x cost for defects in design because you haven't done anything yet.
Right.
Right. But once that defect slips down to implementation, where you're actually coding it, you've already done the design, you've already planned to do the work, and now you're doing the work, and then you discover the defect as you coded yourself into a corner, there's a 6.5x cost now. 6.5x over the 1x of finding and design because you planned it, you spaced out the work for doing it, or this time for doing it. You got the developer that actually did the work, probably wrote the test for it first, and now we're discovering that this stuff isn't going to work.
So that's literally 6.5 money.
Yeah, it'll cost you 6.5 times more. Now, if we continuously deliver this code and we get it all the way out to QA, for example, and then the QA person finds that defect, now we have the cost of deployment if we haven't succeeded with continuous delivery fully yet, and we're doing some manual deployment. We had to have multiple people look at it, review it, and approve it. We get it over to QA. The QA team starts running their exhaustive tests on it. That maybe takes several hours or whatever. So the QA team has now run all these tests, and then they find the defect. Now they've got to log the defect, ship the defect back to the development team where we have to plan a fix for it and design the fix and then push that into our sprint, and somebody has to fix it, and then it has to go all the way back to QA again.
Wow.
That costs 15 times more than finding that defect in design.
And effective continuous delivery eliminates all of this.
Because we've automated testing. We've made sure that the tests are pushed much earlier in the delivery pipeline instead of waiting until after. So doing the testing, right, doing test-first development or test-driven development, as we discussed earlier, before we do the implementation means that before we do anything bad, we've already got the test out there that says, hey, you did something bad. So we don't have to do testing afterwards and find it in QA where it costs 15 times more.
That paints a really clear picture of how important it is. That's good.
The last piece there is maintenance, all the way out to production. Mm-hmm. So 15x cost over finding it in design if you find it in testing, but it's 100x cost if you find it in production as opposed to finding it in design. And it's not that big of a cost jump, but there's soft cost there.
Okay.
Right? Your reputation.
Right.
You suck. Your team's a joke. You write bad code. You deploy bad code. So now you have reputation costs, loss of confidence in your ability to deliver.
Right.
So it's 100 times more costly to find those defects in production because it's probably your customer that's going to find them.
Exactly.
So then the customer's unhappy. They've got to log the defect. It's got to go all the way back to design. It needs to be planned. It needs to be implemented. It needs to be tested again, and it needs to be deployed all the way out to production again. So this is why I say follow the Stairway to DevOps and make sure that you've mastered test-driven development, agile development, and continuous integration before you move on to continuous delivery and before you even consider trying to continuously deploy defects into production.
Yeah, that's a really good point, because if you're finding defects by the time the customer gets it, then you're just working for free. They've already paid for it. You've got to go back and retool the whole thing. That's
Depending on the pricing model that you use, but yeah.
Right, gotcha. Depending on the price, there you go.
Anywho, I think that's all we've got for you for what is continuous delivery. We'll dive a little bit deeper into what is continuous deployment on a future post, along with a little more depth on continuous integration.
And we have another show we want you to watch.
Oh yeah, just FYI, we published a pilot episode of a show that we're calling currently, a series that we're calling currently, Nerds with Beers.
NWB.
So we do that in 360. So if you've got your Gear VR, you can put your goggles on and get out your remote control, and you can pan and zoom and look around at what we're doing in the bar while we're having our beers.
Or you can just scroll on your phone if you don't.
Or you can just scroll on your phone. But if you want to join the nerds, get your VR headset.
That's the true.
We'll put a link to that one in the description as well. But I think that's it. That's all. You got anything else?
That's it. That's all for me. Thank you guys for watching. We're going to be doing this more often. Don't forget to comment. Don't forget to like and subscribe. And we'll see you guys next time.
Peace.